So up there it says Ryan Ellis, Principal Solution Engineer, Snowflake. What it doesn't say is for the 11 years before my 2-year career at Snowflake, so I've only been with Snowflake for 2 years now, but for the 11 years prior, I worked at Micron. So it makes a lot of sense that I would be up here, right? So if we take the way, way back machine, and we rewind 13 years, you'll find me fresh out of college, super excited to start at Micron. And where they started me was interesting, to say the least, right? During my interview process, they offered me a job as a software engineer, and I said, no thanks, I don't want to do that. I want to work in the BI area. And they said, no problem. We're going to put you in this hybrid position where 75% of your time you do BI work, and 25% of the time you're going to do software engineering. And I was like, okay, sounds good, I can do that. I start, 125% of my time was writing ABAP in SAP. For those of you smiling, you know what that is. It's not fun. It's hardcore software engineering, and I was not having a good time. But through the years, I evolved, made it into the BI space. Fast forward to 2013, that's when I met Tony. Micron had just purchased Elpida, and I happened to be the person that was in charge of the BI reporting space for SOX in the fab area, right? So Micron has fabs. We got to report on cost of goods sold, so on and so forth. When I left, before I came to Snowflake, I was their lead principal cloud AI architect, which is just a really fancy word for supervisor of all the cats, right? So that's my journey to where I'm at today. And now I'm going to hand it over to Tony, and he's going to kick us off.
All right, thanks, Ryan. So my name's Tony Money. Obviously, I'm director in smart manufacturing and AI. I very much wanted to wear that outfit today. Somebody said I was not allowed to do so, but regardless, having some fun there. So my department, Smart Manufacturing and AI, what the heck is it? Well, we build ML AI solutions, not just for manufacturing, but for all of Micron. We've got a pretty large department, globally distributed. My particular teams are responsible for solution architecture, data governance, and platform management on things like Snowflake and other cloud solutions. Alrighty, so what we're going to be covering today, a little bit about our journey, how we got there, some technical information, things we ran into along the way, things that helped, tools, automation, some of our success stories that we've had, and a little bit about things where we're heading next. So how did we get here? So a part of my journey, I started off as a C++ distributed systems engineer. I worked on tool automation, integrating things into MES, ERPs. Eventually I became more enterprise architecture focused, working on mergers and acquisitions like Ryan mentioned, mostly in Asia, large systems, learning how to integrate to other people's MES systems, et cetera. But my career took a turn in about 2012 where they wanted me to refocus onto quote unquote big data. So this presentation will talk a little bit about from that journey where we started and where we're at today with our unified platform approach. So a little bit about Micron. Most of you probably know who we are, but in case you don't, we're a little company that started in 1978 in Boise, Idaho in a dentist office, believe it or not. Weirdly, we're headquartered there. We're about a $25 billion company in Fortune 500. We're really proud of our patent portfolio. For a company of our size, 58,000 patents plus growing is very nice to brag about. We have a lot of manufacturing sites, which is where kind of our journey begins. So specifically to manufacturing, where are we located? Well, we're all over the planet, but these are big centers where a lot of our data collection things come from. So we've got a couple of locations here in the United States, in Idaho and Virginia. Sorry for the eye chart, it's pretty small. And of course, we're in China, Japan, Taiwan, multiple locations, Malaysia, Singapore. And when you're trying to get a global view of your network, whether it's for quality, yield, et cetera, this can present some challenges. So where did we start? We've been doing quote unquote big data things for quite a long time. So we make computer chips. They are RAM, DRAM, NAND, flash, goes into your phones, your cars, HBM memory for GPUs. We test the heck out of those things. So if you imagine if you have a 16 gigabyte computer chip that stores memory, if we test every 1 and 0 on those chips, all that gets stored into files, which is it's a lot of data, petabytes and petabytes of data. So originally what we did is we had a file data lake. This is before the days of Hadoop. So think SAN, NAS type of filers indexed with OLTP systems where we could read it. And our engineers got very good at a programming language called Perl. Some of you may know it, some of you may not. And the reason it was popular is because it was very good at doing things like regular expressions. And a lot of this data is semi-structured. So think like XML, but not. It's kind of proprietary formats, and it's a lot of it. But again, because of our scale, we kept growing. We kept buying more companies, going to more countries, and getting that global view. We were like, we should really think about a centralized data lake. So, intro to Hadoop. That was our first journey. Back then, everybody was kind of doing it. We decided to stand up not just one, but 2 Hadoop clusters. We wanted some in our APAC region, and we wanted also in our US region. So we created a system to do what we call dual ingest. More on that in a minute. So very popular, scaled into it, but after we got there, we had a lot of systems, whether it be a REST API or a Tableau report. Very bad user experience when you click a button in Tableau and it takes minutes for the result, because you get Hive jobs to spin up or some Spark thing that kicks off. Not happy at all. So intro, we need more. Let's add MPP systems to this thing. So again, on-premise type of stuff. So instead of having a dual ingest system, we ended up going what we called quadgest. I didn't come up with the names. So quadgest was central, dual replication, both continents, also into the Hadoop system, but then also into the MPP systems. Now, not all 100% coverage from both, but we wanted it in Hadoop for our data scientists, and we wanted it into the relational system, so it was a lot of maintenance. But with that speed and power and this brilliant architecture that we had devised came some problems. So with that, I'm going to turn it over to Ryan, and he's going to talk about some of the technical tenacity and hurdles and things that we had to overcome to get there. So go ahead, Ryan.
Skew, spool, stats. Like everyone's had those, right? Everyone's seen that. You know what we're talking about when we say, hey, these are problematic for us, right? We've taken those mountains and mountains of data produced by fabs from all over the globe. We've jammed them into 2 different places, and now it's very, very fast, but some things aren't so fast. Or some things are fast today, but tomorrow they're really, really slow, right? So we have some problems. We know something has to change, but we're not totally sure yet. Okay, let's fast forward. It's now 2018. It's summertime. It's really, really hot in Boise. Sometimes, like last Saturday, it was 100 degrees in Boise. In May? Are you kidding me? Well, one hot summer, our MPP, it fell down. Like literally fell down. No ingest pipelines were running, no queries were running, no Tableau dashboards were up. We were in a bad position, right? So obviously, Director of Data and Analytics, he said, something's got to change. Who do we call? We call Tony Money. Tony Money is our enterprise architect at the time. What does Tony say? Any guesses? Give me a hand. More machines. That was definitely the answer we got from the incumbent vendor. Right? Tony says, well, sorry, Director, I have something to tell you. FYI, I quit. I'm going to go hit this startup in Montana, and I'm going to go work there. And they say, who's going to drive the bus? If Tony Money's not going to drive the bus, who's going to do it? Tony, good friend that he is of mine, said, Ryan Ellis. Ryan Ellis should drive the bus. Oh, and Ryan, you should go look at this new company called Snowflake. Right, so this is 2018. We're over 6 years ago. Snowflake is a much different company. So we decided we're going to go do a bake-off. That bake-off is going to be against the incumbent vendor, SQL Data Warehouse, and Snowflake. Very, very quickly, we found gaps. Right? So I'm with the SQL Data Warehouse team. We've got all the pipes pointed. It's running. It starts to come under immense pressure. And we say, okay, scale up. And they said, well, you got to turn everything off first. Oh, well, one person just dropped out of the race immediately. Okay? So now we're down to the incumbent vendor and Snowflake. So now plans had to be made. So as your standard enterprise company, we wanted to do it all at once. Migrations cost time. They cost money, right? So we developed a plan that we called the Big Bang. The Big Bang was 4 phases. We need to go find out everything we're using in our current MPP solution, right? In your data warehouse systems today, you have tables that are accessed maybe never, maybe once or twice a quarter, maybe once or twice a year, right? Those are less important. Well, not only do I need to get those, but Snowflake offers me schemas. I've not had schemas before. That's going to greatly reduce my database footprint, okay? So once I go and I create my table list, I'm then going to need to deploy it, right? So I need to make a DDL generator. Inside of Snowflake, I have a few more objects. So I'm going to have to create that table, an internal stage, file formats, and then Snowpipe, right? So we go create that solution. And then, of course, we just called it the DDL deployer. The names don't get good until number 4 when we get to Snow things. But the DDL deployer says, hey, all that work you just did, let's smash those Snowflake interfaces and see if it can handle it, right? So within hours, and I literally mean minutes at this point, of signing the Snowflake contract, we had deployed over 10,000 objects, and data pipes were running and loading data into Snowflake. So number 4, this is, the creme de la creme, Snow things, SnowSQL, Snow Machine, Snowcat, Snowblower. We kind of maybe got a little carried away with the naming system there. Okay, Snow Machine. Snow Machine did the majority of the heavy lifting for us. So with any kind of migration, your ETL tool of choice matters. And if you're on legacy tools, I don't want to call anyone out, but there's a lot of legacy ETL tools that are very metadata hungry. Metadata hungry meaning if I change that pipeline in any way, it won't refresh. It'll break. My data pipeline is down. Someone's got to go physically open it, refresh it, recompile it before it goes again. Apache NiFi, so 6 years ago, Micron's using open source Apache NiFi. It's not metadata hungry. I can add columns on the fly. It doesn't care. Not only does it not care, I can take that exact same data pipeline that I'm feeding the MPP with, and I can say, hey, keep doing that, but also start feeding this system over here, specifically Snowflake. So I'm now able, without having developers or a fleet of engineers go touch every single ETL pipeline. Remember, there's tens of thousands of tables in this MPP, but I'm able to fork it, keep my MPP up and running. The business is struggling, but we're gonna get their dashboards refreshed every once in a while. I've now forked all those data feeds over to Snowflake, and it's currently loading that system, okay? This is all during our POC stage, right? Okay, 6 years ago, how mature was the Snowpipe API? It wasn't, I'll tell you that right now. If you think about of a child, it was a toddler, right? Sometimes it would give us status code 200, the data never got there, right? So you'll see this guy here in the code here, a guy named Paul Gerbeau. Paul Gerbeau is an absolute wizard. If you ever have a chance to meet him, you'll get the same impression. He created what we call NiFi processors that would specifically work for loading data into Snowflake. And him working hand in hand with the Snowflake API, or the Snowpipe API team, really ironed out a lot of those kinks to the point where we could trust that system and bet our data feeds on that system. So Snow Machine takes all of our source data from all of those fabs worldwide, there's 9 of them right now, and it pipes them all into a single location. So we're not doing dual ingest, we're not doing quad ingest, we're now piping it to one location. That's a good simplification. Okay, the data's inside. It's in an internal stage. I've called Snowpipe. It exists in let's just call it a bronze layer. It's very raw, nothing's happened to it. In comes Snowcat. All the snow has fallen, I need to groom it. So one JavaScript stored procedure to rule them all. So most of you are like, JavaScript, why would you do that? Just use a SQL stored procedure. 6 years ago, no such thing. Only JavaScript existed at the time. So what this JavaScript stored procedure does is it takes the contents of that table that was just loaded by Snow Machine and checks, hey, do you exist? Do you exist meaning file name is database, schema, table name, timestamp. Oh, you don't exist? Cool, I'm going to create you. What's another parameter that I passed in? Well, this is a full load, which means every time a new file drops, I only want the contents of that file. But I could be a delta load, which means only give me the deltas, right? So Snowcat is called tens of thousands of times an hour because these data feeds that come out of all these fabs globally Fabs run 24/7, 365. They never stop. At 15-minute increments, I'm dropping tens of thousands of files that the Snowpipe system has to keep up with. My Snowcat system then has to go and level out for us. But you know, if I have a ton of data loaded into these internal stages, what's going to happen? Anyone? They're going to get built up. Why am I keeping so much data around? So I have to have something that goes and cleans up after myself. Snowblower. Anyone catching the theme on what we're doing here? Perfect. Okay, so snowblower, every 7 days is going to go look at all those internal stages, and it's going to delete anything over 7 days old. Right? Why do I keep at least 7 days around? Because back in our MPP days, we learned Micron is a company of engineers. Everyone has an engineering degree. All the people in the fab walking around, they know what they're doing. So when their data is wrong, they do not wait to tell you. So you know immediately when a data feed is not correct. And so the ability to go back 7 days, at least in history, and pull in what they're missing, extremely valuable. Okay, we've talked a ton about how we did it as an IT/SMAI team. What about the business, right? Do those people matter? Do we have business people in the room? Anyone? We're all IT people. Oh, I saw one hand, 2 hands. 2 people were brave enough, 3, to admit that there are consumers of Snowflake data. Okay, there was around 4,300 Tableau workbooks that needed to be brought along, right? So how do we take, and these are, again, dual ingest system, some in Boise, some in Singapore. We called it SnowSQL. Yes, we know there's a product called SnowSQL, but we created our own. And it was just a very simple web IDE that allowed people to take their Tableau notebooks, or excuse me, their Tableau workbooks, take the SQL out, paste it, and behind the scenes, we were going to rewrite that SQL for them because, again, 6 years ago, Snowflake wasn't at feature parity for SQL commands and syntax. And then 2, remap it, right? So our old MPP only had databases and tables. We now had schemas. So copy, paste, convert, copy, paste. That's pretty simple, right? So what we did is many hands make light work. So rather than have to take a fleet of data engineers to go convert everyone's notebook, test it, validate it, we said, hey, business, here's an interface. Take your code, copy, paste, it's going to work, right? So we involved them in the journey, gave them a way to be included, and they loved it. Very, very simple interface for them. Okay, semiconductors. They are 100% a strategic investment. You'll look at every administration on the planet. They don't allow certain chips, certain memory types, GPUs to go to certain countries, right? So data is very, very important. Not only is it very important to not get into certain places, but it's very important not to get to certain competitors, right? So if you are a semiconductor and you own the technology stack for a certain design node and you're 3 designs ahead of the competition, that is a multi-billion-dollar profit that you're going to experience. So if some of that data walks out the door with one of those engineers and goes to a competitor, not only did they leapfrog multiple design IDs, but now that competitive advantage you had, that money you were making off of that R&D you put in, it's gone. Okay? So obviously security is important. Okay? So question number 1, what happens if I am an engineer in Boise? Boise is their R&D fab, and now all of a sudden I go work in Taiwan in what we call a high volume manufacturing fab, right? My data access should change. So we've had a theme, right? Everything is database, schema, table. So the Active Directory groups that a person is a member of is fab, database, schema, table. So if I change departments, I no longer am part of Fab X. I'm now a part of Fab Y. Every hour snaps the Snowflake auto provisioning system, goes through our 80 groups and says, hey, John has this RBAC role in Snowflake, but he's not a member of this group. Drop. Jane is a member of this group, but she doesn't have that access in Snowflake. Add. Okay? What happens when a new employee is hired? right? So one of my biggest problems, I thought, as a data engineer in the way back days was I felt like at least 50% of my time was getting access to the data I needed to do the job. Well, as a new employee, if I report to Tony, Tony is over XFab's data. His direct employees group rolls up to Fab X data access. So weeks before I've gotten through HR, onboarding, completed all my training, configured my laptop, I have access to the data inside of Snowflake that I'll need to do my job, right? Reducing that headache for me. And then again, what if I need special access, right? So if you're familiar with semiconductors at all, you know what about, we call something an excursion. So an excursion is basically something bad happened in the fab, right? So we might stand up a special tiger team to go investigate that thing that happened. And to do that, I might need access to data that I typically don't have access to. Again, I get added to that AD group. It has an expiry. I do the investigation. And then an hour later, Snaps runs, and I no longer have the access. Okay, automation, right? That all was a ton to take in. Three very key takeaways. Don't touch it if you don't have to, right? And what I mean by that is if you are planning a migration or you're looking to do something, if you have to physically have an engineer go open every data pipeline, you've already failed, right? Write code to make that happen for you. Alligators, they're kind of scary. This one I do need an answer for, though. What do alligators do? We're not going to move on until someone says it. Bite. Oh, I love it. Alligators bite. Who likes to get bitten? I know data engineers don't. Directors don't. VPs don't. Nobody likes to get bit. So when I say identify your alligators, there are data pipelines, executive dashboards, data feeds that for sure cannot go down. Whether it's that fiscal quarter end dashboard, whether it's your yield analysis or whatever industry you might be in, identify your alligators and know who they are and make sure your plan, which is measure 3 times, cut once, plan, and then plan again to enable your success. Okay, to talk about the success, we'll give it back to Tony.
All right. Thanks again, Ryan. So happy customers. Well, you can't make everybody happy all the time, but to share a little bit of what we have seen. So the 3 S's are now, for the most part, gone. A huge piece of it is our platform stays up. By moving to this infrastructure, right, we've gained a lot of pieces of resiliency, scale, but a real key one I wanted to call out is our security team. We are in a position now, especially with our Snowflake deployment, that they are very happy with, right? We use private link, we're tri-secret secure, we have customer managed encrypting keys, we have all kinds of things that they have wanted over time, so it was a great partnership and benefit to have them be a champion for us. Performance, equal and better. Performance with small, medium, so this ability to scale to what you need and also subdivide things, right? So we dedicate warehouses just for ELT or just for a particular business transformation or maybe some backload or some big job. We stand up a temporary extra large, double XL, whatever, right, just to do these things. And so in a lot of the platforms we've had in the past, we didn't have that flexibility. So 3 key things there that helped us out. We love it. Cost, this is always a tricky one. So in general, I'm going to say feel, because we don't keep track of detailed metrics. Again, some of this stuff happened quite a while ago, but we feel that Snowflake is pretty much half of what, I know it was when we first started doing half of what it was for our MPP solution. But even now, 6 years later, we still feel like we're paying less than if we would have tried to scale those MPP systems, right? We've taken duplicate sites, we've consolidated to one, we've got scale, we're saving money. We didn't reduce headcount. You'll see that middle column up there like by 50%. But what we were able to do is dedicate engineers to certain tasks and have less reliability on IT teams, DBAs, network teams that were responsible for some of these on-prem systems, and they can focus elsewhere. So big cost advantages for that. More productivity, developers, queries in general we do tuning. We get requests for help, but in general, like, it's very self-service. The problems are just much less than what we used to see. Euphoria, so very, very, very important to us is data science. We have, in my department alone, a tremendous amount of, over probably half of our department is made up of data scientists. But we are global. They're all over the planet. We're not just in manufacturing. Again, we do sales, we do finance, and all the different departments, right? But most of them are centered through us. But what they like is they don't start seeing these differences because we don't have it in so many places, right? It's a single source of truth. Like the SNAPS program we talked about, their access, they don't have as much trouble going through weeks of tickets. Hey, when am I going to be able to see this view? Yeah, back to the just time to market, time to access for these folks. And a little bit about now. So what are we doing now? So that's all kind of history. Where did we start? Where did we get to? What are we thinking about now? SAP is an interesting piece of our story. When we first started this journey, our SAP team is more in the IT area, and they did look at joining us to go into the Snowflake world, but they chose not to. Primary keys were a big holdup for them at the time. HANA was kind of the hot thing for them. But 5 years into this journey with HANA for them, they were having constant problems with HANA. Pressure on memory, contention, again, lack of scalability there. There's no elasticity in that. So our CIO met with my VP and was like, hey, the big data team is doing pretty well here. Maybe you ought to look at moving that over into Snowflake. So a year later, boom, SAP is now in Snowflake, and they were able to retire 3 different warehouses. Again, duplication, Oracle, SQL Server, huge overlap there. Don't ask me why, how we got there. But huge overlap, and then HANA itself. So again, back to the single source of truth. So this has been a big win for us, and it's still an evolving journey, but fairly recent. Gen AI. You can't have a presentation and not talk about AI. So what are we doing there? We are very excited about Cortex and its capabilities. We are not only doing things with the platform itself, but we're also trying to utilize APIs and build custom applications and, I'll say talk to your data, if you will. Another key aspect of that, because of some of the restrictions like Ryan talked about, we have absolute need to be able to control which models people have access to within the platform. So we need to be able to say, yes, that one, not that one. DeepSeek, for example, is something that people might say, nope, don't do that. So having that kind of RBAC type of controls there is very important to us. And we are seeing good speed from the Snowflake team. Like, I think we were just talking to a product team. I don't see them in the room here, but was it Claude 4, Sonnet 4, whatever, almost instantly available on the platform. So that's important to us too, because we have so many data scientists. They really want to try out and push the boundaries of these new models as they come. So that's kind of where our focus is in Gen AI. We have lots of different types of use cases. If some of you want to connect around that topic, please do. Happy to share some of that kind of stuff. But in general, you could say search and summarization are the key easy ones, right? We do a lot of that. And so I think it's important to maybe share internally. Sometimes we're not very good at doing this, just to give you an idea of what do we do. Like, are you the same kind of company as us? Maybe you're much smaller, maybe you're much larger. But this is pretty much what we have at our enterprise scale. We got about 2 petabytes of data in our Snowflake platform, about 1,000 databases. And you can see the numbers here, I don't need to read them all to you, but thousands, hundreds of thousands of tables, views. This is our session average, about monthly, about 1.6 million a month, and then lots and lots of warehouses. And then that number, of course, ebbs and flows because we use our warehouses very dynamically. One month it might be 700, the next month it might be 2,000, so we're very flexible with them. So, kind of to summarize, where did we end up? From our custom file data lake using Perl to Hadoop and Spark and painful reaction times, I guess, or response times, to an MPP that we literally buried, just knocked it over, to Snowflake. Impressively, and big kudos to Ryan, the entire Snowflake team. We drove the engineering teams at Snowflake very hard back in those days, but they were able to move this all in 4 months. Very impressive number. Why? The investment in the automation, and that it's not about NiFi. It was about the investment in the automation, that ETL layer that allowed us to immediately take these pipelines and duplicate them, fan them into different sites, countries, like that infrastructure. We would have never been able to achieve that without investing in that infrastructure. To this day, we run it constantly. We have another tool that we didn't talk about called PBR, which stands for Pipeline Builder. And what that does is it allows us to not only move files and data around, but it allows us to point at a database somewhere on the planet and say, I want that table and that schema, and I want it over there. So we've built the connectors. Again, you can check out Paul's GitHub. And we've partnered. We have 2 team members that were in the Apache committer for NiFi, and they built connectors into SQL Server or into Postgres that you can do CDC change capture right from NiFi straight into the platforms. And so massive advantage for us.